On this slide, I'll review the results of our study examining the effects of caffeine ingestion on ratings of perceived exertion, also known as RPE, during resistance training. First, looking at participant characteristics, we have a total of 11 participants. The average age was approximately 26.9 years, with a standard deviation of 8.7 years, indicating some variability in age, but generally a young adult sample. The average body mass was 84.8 kilograms, and the mean height was 177.2 centimeters. The sample is primarily male, as reflected by the coded sex mean of 1.36. This means that we used 1 and 2 to represent male and female. Overall, this provides context that our findings reflect responses from a mostly young, active population. Now moving to the primary outcome variable, ratings of perceived exertion. RPE was measured on a 1 to 10 scale following upper and lower body resistance training sessions under two conditions: no caffeine and caffeine ingestion. Under the no caffeine condition, participants recorded a mean RPE of 5.55 during upper body exercise and 5.82 during lower body exercise. These values fall between moderate and moderately hard effort. When caffeine was ingested prior to exercise, RPE decreased to 4.73 for both upper and lower body sessions. This represents a reduction of 0.82 points for upper body and 1.09 points for lower body exercise. In practical terms, participants consistently reported about 1 point decrease in perceived effort on a 10-point scale when caffeine was consumed. Although a 1 point difference may seem small numerically, on a subjective effort scale, this is very meaningful, especially in resistance training, where perceived effort influences fatigue, performance, and adherence. Looking at the statistical analysis, paired sample t-tests showed that these reductions were statistically significant. For upper body exercise, the difference between caffeine and no caffeine conditions was significant, with a p-value less than 0.001 and a large effect size of 2.02. For lower body exercise, the difference was also highly significant, again with p less than 0.001 and an even larger effect size of 3.62. These effect sizes indicate a very strong practical impact of caffeine on perceived exertion. Additionally, the repeated measures of NAOVA revealed a significant main effect of caffeine, meaning across exercise types, caffeine consistently reduced RPE. There is no significant main effect of exercise type and no interaction, which suggests that caffeine's impact was similar for both upper and lower body exercises. Overall, these findings indicate that pre-workout caffeine ingestion significantly lowers perceived exertion during resistance training, regardless of whether exercise involved the upper or lower body. This suggests caffeine may be an effective aerogenic aid for reducing subjective effort and potentially improving workout tolerance or performance.